The GuideRight surgical guide system is a geometric approach to guided surgery. The components are comprised of straight and offset guideposts, guide sleeves, guide sleeve inserts. The angle of the guideposts are correctable with the bending tool in two planes, mesial-distal, buccal-lingual. In this case, showing a maxillary second molar replacement, featuring linear and angle corrections using the GuideRight two-piece guidepost is presented. The GuideRight Protocol requires a diagnostic guide fabrication for the initial evaluation. These are the steps that we must follow. A hole is drilled in the cast with a 3/32 drill in the edentulous site where the prosthetic planned long axis of the implant will be. While a diagnostic wax-up may be helpful, it's not always available. A hole is drilled in the cast with a 3/32 split point drill and a laboratory handpiece to create a proposed planned prosthetic position for the implant placement. A 30 mm straight guidepost has a top end that's 3 mm in diameter and the lower end with a 3/32 inch diameter. The small end is placed in the hole in the cast, which has been made with a 3/32 drill. A 3 mm diagnostic guide sleeve is placed over the top part. The guidepost represents and captures the prosthetically planned implant axis. If there are undercuts in the adjacent teeth, they should be blocked out with wax before adding the separating material or petroleum jelly or rubber set. Triagel is added to the guide sleeve and several of the adjacent teeth to fabricate the diagnostic guide. Anatomage in Vivo 5 or another software program is used to evaluate the position and angle of the diagnostic guide sleeve in the three-dimensional cone beam image. The guide is placed in the partially edentulous patient and carefully seated before taking a cone beam X-ray. Cotton rolls can be used to secure the guide in place as the patient closes down on them. A virtual implant selected from the implant software library is placed in the image of the cone beam X-ray. The virtual implant positions are used to evaluate the position of the guide sleeve and the planned implant position in relation to the adjacent teeth, alveolar bone, mandibular nerve, sinus, and other anatomic structures. There are three views that are evaluated in the in Vivo 5 X-ray image. The axial view, the cross-sectional or buccal-lingual view, and the tangential or mesial-distal view. To begin the evaluation, a virtual implant is placed in line with the diagnostic guide sleeve in both the tangential or mesial-distal plane and the cross-section or buccal-lingual plane. The line in the axial view in the upper left corner of the screen indicates the slice being observed. It must be positioned at right angles to the arch. This aligned position of the implant is referred to the home position. All measurements and corrections should be made from the home position. Next, move the virtual implant to the preferred implant position. Note that the implant position is no longer aligned with the diagnostic guide sleeve. In this case, the preferred implant position would require a linear correction to move the 5.5 by 8.5 millimeter implant 2.5 millimeter distally to the desired position. The in vivo software grid should be turned on. It is comprised of intersecting lines forming a grid with each square measuring 5 by 5 millimeters. The length of each side of the square measures 5 millimeters, and the halfway length measures 2.5 millimeters. The grid is used to make the measurements of the corrections in both planes. A higher magnification of a 5.5 millimeter implant location in the tangential view shows the desired linear correction to be 2.4 millimeters to the distal, slightly less than 1/2 the length of the grid square. According to this cross-sectional view, A small angle correction of 5 degrees palatally is needed to center the guide sleeve over the long axis of the desired implant position. The buccal-palatal position will also be changed approximately 2.1 millimeters palatal. In order to correct the guide sleeve, the positions both distally 2 millimeters and palatally 2 millimeters, we're using a 3 millimeter offset guidepost and rotating the guidepost 45 degrees. The guidepost will also require an angle correction of 5 degrees toward the palatal surface. To correct the guide sleeve position distally by 2 millimeters, a two-piece 3 millimeter offset guidepost is used. Again, it requires an angle correction of 5 degrees toward the palatal direction as indicated in the in vivo 5 X-ray. To correct the guide sleeve position both distally and palatally by 2.1 millimeter, a two-piece guidepost offset 3 millimeters is selected. The 3 millimeter guidepost will be rotated 45 degrees, and using the Pythagorean theorem, the cosine of 45 degrees, which is 0.71, is multiplied by 3 millimeters, resulting in 2.13 millimeters of correction in both the distal and palatal direction. A 3 millimeter offset guidepost is placed in the hole in the block. It is rotated 45 degrees, and the set screw is tightened against the flat side of the post. A stylus is placed over the post and used to bend the post the required 5 degrees. You may view more explicit instructions on the use of the bending tool at www.dplaque.com. The next step is to refabricate or make a new surgical guide using the same cast and hole in the cast by placing the corrected guidepost rotated distal palatally. Choose an upper guidepost and a matching guide sleeve based on the diameter of the drills that will be used to prepare the osteotomy. This is an occlusal view of the 3 millimeter offset lower two-piece guidepost rotated 45 degrees in the distal palatal direction. When the 3 millimeter guidepost is rotated 45 degrees, the Pythagorean theorem again is used to determine the new position of the guide sleeve. Multiplying the cosine of 45 degrees, which is 0.71 by 3, equaling 2.1. Therefore, the new position of the guidepost will be both 2.1 millimeters palatally and 2.1 millimeters distally from the original position of the diagnostic guide sleeve. A 3.8 millimeter top part of the two-piece guidepost is selected and placed on the lower part of the two-piece guidepost after it has been rotated 45 degrees. A 3.9 millimeter guide sleeve is placed on the top part of the guide post. Triad gel is added to capture the cleat of the 3.9 millimeter guide sleeve and the occlusal and palatal surface of several of the adjacent teeth to form the surgical guide. The more teeth that are covered with the triad gel, the more stable the guide will be during the surgery. And don't forget, the cast has to be lubricated in order for the surgical guide to be removed. Triad gel is cured with a curing light to capture the cleat and the registration on the adjacent teeth to form the surgical guide. In this view, a 3.9 millimeter guide sleeve can be seen without the top part of the two-piece guidepost, showing how the guide sleeve has been centered on the corrected, rotated 3 millimeter offset guidepost. This is a front and side view of the initial 2 millimeter, 5 millimeter long pilot drill which will be used. It has a 3.8 millimeter diameter depth stop placed in the 3.9 millimeter posterior angle cut guide sleeve. A second 6 millimeter surgical guide was also made using a 5.9 millimeter guide post on the same lower part because the implant that will be placed will be a wider 5.5 millimeter diameter implant to compensate for the short length. A view of the secondary 6 millimeter diameter surgical guide with the post removed shows the guide sleeve centered on the same lower post, which has been rotated 4.45 degrees distally and palatally. To place the implant, an incision was made with the flap reflected toward the palatal. A 2 millimeter diameter, 5 millimeter long, with a 3.9 8 millimeter depth step was used to start the osteotomy in the 3.9 millimeter guide sleeve. This was followed with stock manufacturer's drills to deepen and enlarge the osteotomy by visually centering the drills in the guide sleeve. Post-operative cone beam X-ray agreed to by the patient was taken to check the position of the implant. This is the image of the final implant placement. A periapical X-ray was also taken at the second stage surgery, which further verifies the position of the implant where we wanted it to be placed. This is the buccal view of the impression coping in the master cast. This is the buccal view of the master cast with the final screw retain restoration. The screw retain restoration is a cast to abutment and crown. This is the occlusal view of the final restoration. You can see the hole in the cast part in the metallic part of the crown to tighten the abutment screw. And this is a picture of the final restoration completed. The access hole has been filled with composite. Thank you very much for watching.